Hey, thanks for listening to the Aftermarket's premier podcast that connects you and your peers into an audio networking group for sure. Carm Capriato here, your aftermarket podcast guy. Hey, we bring you the most relevant and on-point automotive aftermarket content in the industry. Check in with your friend and ask them what they thought of this episode. Hey, today we're going to talk about Advanced Driver Assistance Systems, or ADAS. Joe Register is the Vice President of Emerging Technologies at the AutoCare Association, and he's back. 1 week ago, we talked about secure vehicle interface, and this is our follow-up with Joe. He's brought enormous amounts of helpful information on the advancement of technology to you, my listener. And there's also slides you can actually watch the video too. Go to the show notes page. Joe Register has got over 40 years of experience delivering progressive systems solutions to companies in every channel of the aftermarket. Joe's well connected through his work in helping to create tech and interface standards with ISO, the International Organization for Standards, and of course, SAE, the Society of Automotive Engineers. Now, hey, we've got two great partners that support this ADAS discussion for you, Virtual Apex and Shopware. Now, Virtual Apex Experience, November 3rd through the 5th, 2020, is going to be the hub of free training for shop owners, technicians, and service advisors here in 2020. Several Apex exhibitors, including Drive Garage Gurus, Autel, Bolt-On Technology, Bosch, Hunter, and Napa AutoCare will be there with their training. I've interviewed so many of the trainers that are part of Virtual Apex, so proud of them being there. Now, make the smart move, register, because registration is required on the web at aapexshow.com/register. And now is the time to transform your shop, break away from your legacy SMS, shop management system, and embrace Shopware's shop management system. Shopware can show you the way to increase profits from happier customers and a more efficient staff. And who doesn't want that? Visit getshopware.com for a free preview. Go online. Visit getshopware.com/carm for a free demo. Hey, the key talking points for this episode with Joe Register are at remarkableresults.biz/E584. You'll also see the video of this recording on that page and the slides that Joe references.
There wasn't 50 bytes an hour when we started in this business back at the OBD port, right? But now 4.5 terabytes, billions of bytes running through this vehicle. And this is 2023.
Now, more with Joe Register in a minute. Hey, no doubt this episode will broaden your horizon as it relates to the tech we deal with today and well into the future. The more you learn, the better. So many said back in the 80s, this fuel injection stuff is just a fad and it won't last. Now, they paid a price for not adopting and learning the new technology. Now, I believe you understand that today, which is why I say the more you know, the better. Hey, you're watching the new show, AftermarketWeekly.com. It's a live show every Tuesday noon Eastern Time. Every episode is available on the website, and you'll find really fun and interesting topics, all aftermarket focused, and it includes a shop tour. Now, we've been to shops all over North America, and you may just take a great idea from one of them. AftermarketWeekly.com. Binge on all the past episodes. Hey, so many of you listen while you're multitasking, and I know that, and I appreciate that. And that's what makes podcasting so cool, is you can listen wherever and whenever you want. That's the power of on-demand audio, and you can always complete the episode where you left off anytime your schedule permits. Hey, a warm welcome to Joe Register.
Hey, Carm.
Hello, Joe. Emerging Technologies. So that everyone knows, and I'm sure you appreciate it, we just recorded a great episode on secure vehicle interface. Thank you so much for that, Joe. And we stayed in the studio to do this round 2 on ADAS. Can I share with you a really cool story? I was at a demo, I think it was a month ago. A friend said, hey, come on over. Hunter's kind of doing this demonstration. And it was at a fire hall, and I live in the country, and it was really kind of a cool environment. And they said, hey, why do you think we have green lasers now that align these ADAS calibration units? And I raised my hand right away, Joe. And I didn't know if I was going to be laughed at or what. And I said, I can't see red lasers. I'm colorblind. And he goes, bingo, you're right. The percentage of males that are colorblind, and now they have green lasers. A presenter goes up at a conference and they're showing their little red laser on a screen. I have no idea where they're pointing.
It's amazing, isn't it? I mean, those kinds of very simple but absolutely important details are something you only learn when you go and take it out to have people use it.
Well, I'm glad you're here, Joe. Again, let's talk about ADAS. There's so much going on, a lot of progress. I mean, look at our vehicles have so much ADAS on it today. I almost feel brother-in-law bought a brand new car and he's talking about all these things that he's got. Oh my, and it's just a 2-year-old car. And I'm thinking, man, 2 years ago, those cars were loaded. I can't imagine what the 2020, 2021s have.
It's gotten to the point where the amount of sensors that are on the vehicle are numbing at this point. I'm not just talking about external sensors, but which now includes ultrasonic and radar and lidar in some cases, and certainly cameras, and the list continues to grow because, quite frankly, all of these different devices have their strengths and they have their weaknesses. Manufacturers are looking to try and understand what a road looks like through the eyes of these sensors. And it's so different than what you and I see from behind the wheel. We have this enormous computer that's stashed away up here that makes sense of things that machines just can't rationalize the way we're able to. We also can refresh really fast because we persist with a lot of the information that we've collected already. And then we play on top of that. And so only kind of the things that change make a big difference for us. And there's just a lot of work. The Southwest Research Institute, which I know we've talked about before, Carm, we're indebted to them. They're wonderful folks. Michael Brown's group in specific has been of enormous help as we've been working on ADAS. The information that they have available is just incredible. They've been working on something called perception systems, which is to create this composite of all of this information as it comes streaming in, and then to recognize the difference between the rider and the bicycle. Because it's important to know that there's not just a bicycle, but that somebody's actually on it. And if the two become separated, to realize which is the really important piece and which is the other piece that, isn't going to be catastrophic if it's, struck by the vehicle.
When I think about that futuristic stuff, that the Hollywood people have done such a great job of in CGI and all that stuff to either scare us or share with us or to excite us, all of that. We're watching that stuff. How many times do I look at that stuff and I say, someday, all that's going to be real?
Just for fun, we'll just diverge for a quick second and just say, science fiction is the future science, right? I mean, all the way back with Jules Verne and H.G. Wells and all the rest, right? I mean, things are fantasized first, and that's how we work, right? As human beings, we, create things in our minds, and then we bring them to fruition in the material world.
Every day, there's some kind of virtual webinar on ADAS. I'm so happy to see it all. We're at this, if you will, mass point, I believe, in our world that every technician, every loop technician, everyone who works on a vehicle, every service advisor needs to get to an ADAS class.
I think so. It's about as simple as the fact, I'm thinking back to the days now when I started in the business. I remember distinctly that, and I was a parts person while I was still in school. There was a classic, even then, T-Bird. I think it was a 56 that was in the shop. We just put a new motor in and we put new brakes in, and it was a whole complete thing that we were doing. Well, everything was finished except the brakes. And of course, the sign on the front of it said no brakes, but the guy was so anxious to jump in this thing and pull the car out of the garage in the morning when it opened up. He didn't pay any attention, took this beautiful car and boom, right into the, brick wall right in front of it. And you have to learn when you start working in a shop environment, what you can do and what you have to be careful of until it becomes second nature. And everybody has to realize that electronics in vehicles are going to be just as second nature as checking the brakes before you pull out of a stall, right? Quite frankly, we're not there yet. People are with all the best intentions, make repairs on vehicles. The car goes out without the right amount of testing. People can get hurt.
Without the right amount of respect.
That's right. Exactly right, Carm.
And that's where you start applying your common sense, the years you've been in business, the fact that you're a great diagnostician, it's, you see, you feel, you hear, all of that comes into play when figuring out what's wrong, what's right.
Right, exactly. I want to do a shout out, first of all, to our friends at Hunter. And this was a slide taken from the last, we talked before about the Emerging Technologies Committee at AutoCare. And this is the group that I liaison with, some great folks that are working with me. One of them is Ryan Frisch, and he did this ADAS update. Ryan is the chair of our ADAS work group. Hunter Engineering, God bless them, donated some of the work that they had done over years of period of time in calibration of ADAS and et cetera. This is kind of the history of what we've been doing at AutoCare around the ADAS topic. We created our own task force, and the initial input, as I said, was this paper that was created by Hunter. It was actually a best practices paper. So they were taking all the things that they had learned, and they were very candid about, what we've seen are some instructions from manufacturers that are in some cases inadequate, in other cases just plain wrong, and others that are impractical. And we've talked about a few of these over past sessions, Carm. I mean, wanting 40 feet in front of a vehicle to place the target. I mean, I don't know how many shops you've seen that have 40 feet in front of a rack, but I haven't seen too many. That type of thing is they've been collecting for some time.
It pushes the requirements of wanting to do good calibrations to having the right light, the right space, the right level, all of that.
Even cleaning your shop up. One of the most important things that, has been a best practice learning on all this is you can't have junk laying around. You got to clean your shop up. You got to make sure that there aren't a lot of boxes sitting around and debris from past repairs, because that will also throw off some of the calibration that you're doing. Lots of learning, all the way down to the physical plant.
We have to respect it, period. This is how it is. And we could try to break the rules, but I think you're just kidding yourself, because ultimately at the end of the day, when that car leaves, it's got to be right. And I don't think there's a shortcut.
There really isn't. And so, we got together with our friends from SEMA and AASA. This is really a good story of collaborative efforts. We talked about this. It was even at an ETI session, one of their events. So Greg gave us some space, and we all got together and we started talking about this very important subject. And we all agreed that we needed to do something in a formal way in a standards environment. What we felt was, just like with what we did with SVI, having a set of standards, first of all, formalizes what we have to say. The best practices get instilled into the standards, and then the manufacturers know, they have our input based on the standards that we helped to develop. And so we took this time, not to ISO, but to SAE, and made a pitch to them at the beginning of the year and said, look, we've been collecting this information. It's all down in this paper. It's not exhaustive, obviously, but it will get us started in talking about how to form standards around calibration for ADAS equipment. And I'll be darned, they said, let's do it. We got a group together. I think there's now about 35 folks, and they include sensor manufacturers, they include tier ones, and they include some OEs. They include folks from our associations in the aftermarket. It's a nice group of cross functional kinds of disciplines as well, and so they formed a sensor calibration task force within the Active Safety Committee, which is a standing committee in SAE. So now we have a formal place to get together and to work. I'm delighted to say that group elected Ryan Frisch, the guy that was heading up our ADAS effort, as the task force chair. And so now they're meeting regularly every month to start moving this piece down the road to actually end up in a set of published standards.
That's interesting. Sensor Calibration Task Force under SAE. Does that mean to me as I want to put my thinking cap on, that we'll see more dynamic calibration in our future?
Certainly, dynamic calibration is important, and there's a lot of interpretations as to what the heck that really means. The ability for a sensor condition state to be understood by the vehicle is terrific. One of the things that we don't talk about a lot yet, but we will, is that over time, sensors, just like any other part, will degrade in its performance. And it may still work, but it's not doing the job that you had originally designed it to do. And so it gets nearsighted or it gets farsighted. And all those things are part of the aging process.
Are you telling me that there's kind of a lifespan on it? I mean, will it be like maintenance?
Absolutely, Carm. And we just haven't reached it yet, right? I mean, in most cases, these vehicles with this type of equipment haven't been out there long enough to really experience that kind of degradation. But, this is another place where Southwest, and a shout out to Doug Brooks at Southwest Research. He's one of the engineers there, and he's been with us on our task force and helping now on this one. And in addition to the perception system piece, has been doing just this very work, trying to simulate years of use in a shorter period of time. So they have all these torture devices that they put this equipment in and torture them to see when they give up the ghost, but more importantly, when they seem to work but really aren't.
Whoa. When they seem to work but really aren't. You just scared the heck out of me.
Well, I wanted to sober you for sure, but I don't know that I wanted to scare the heck out of you. I mean, the point on all this is that, it can't be overstated, I don't believe, but I don't want to get, dramatic about it, that we don't know what we don't know yet on this car. These devices have all been engineered to great tolerances and all the rest. They go in the vehicle. But, that's not a very nice environment. Vehicles go through some pretty harsh environments. And a lot of these sensor devices, especially around ADAS, are externally mounted, right? So they get bumped and they get frozen and then they get thawed and then they get, all different types of abuse. And what that really means from a standpoint of their performance, how do we know it's giving us the right information? And especially when you start talking about the interplay with them from an integrated whole. So the camera is depending on the radar to do something. The radar is depending on the LiDAR to do something. They're depending on another device to give information. And as a result, that composite may deteriorate with the quality of information coming from a specific sensor or two. And how all that fits together, you can imagine the permutation of all the various pieces of that as you think about the growing number of devices.
Hey, Carm here, and listen to what Joe says about certifying your knowledge about ADAS. Hey, Carm here. Now, the virtual Apex experience happens November 3rd through the 5th, 2020. It will be the hub of free training for shop owners, technicians, and service advisors. You'll find instructor-led training, plus several exhibitors will be there with their training, starting with Drive Garage Gurus. They'll cover topics like engine performance diagnostic strategies, electronic power steering, wheel speed sensor testing and diagnosis, and the top 5 misfire diagnostics. Autel will provide training on ADAS and calibration, using a good vehicle inspection process to document suggested and required repairs to consumers, and how scan tools and lab scopes work together for more complete and accurate diagnosis and repair. Bolt-On Technology will bring us its Bolt-On University to attendees, covering best practices and the Fast Track Your Shop's Success program. Bosch will provide ADAS training, while Hunter Engineering will focus on wheel alignment and ADAS. Kukui and Napa AutoCare will also offer exhibitor-led training and demos. It's all free. Now, to register, go to www.apexshow.com/register. It's as easy as 1, 2, 3. Shopware's shop management system allows customers to review, approve, and pay for repairs all in one place. Now, 1, your customer views their outstanding balance. 2, they are prompted to submit payment directly through their invoice. And 3, Shopware's secure portal facilitates payments right there without having to open another browser or remember another password. It's really that simple. Shopware is your complete solution for contactless service. Let remote pay work for you and improve your customer experience. Get started today. Visit getshopware.com for more information and to request a demo. When I listen to you, and we've done these, I'm inspired by your insights. And one of my big takeaways right now was that if you were going to be an ADAS specialist, as a diagnostician, as a member of an aftermarket service team, and you don't commit to training, I mean, don't go to an ADAS class and think you're an expert, because 6 to 9 months later, you may not know it, but there's going to be a new class to go to because there's going to be new information. This seems like this may be one of the, besides moving from autonomy 3, 4 to 5, this is real. It's in our hands now. We're being affected by it. And I think if you look at your resume and you haven't been to an ADAS class in a year, you better go to another one, right?
It's a great point you bring up. And again, as we move from this world of analog machine types to electronic devices going forward, and then the rate of change, the recertification or retesting component is going to get extremely important. ASE has always said, look, you qualify for, smog certs. It doesn't last forever. You have to go back and you have to retest and so forth. But I think that, that's going to be on steroids with a lot of these systems because of 2 points: their individual sophistication and then their collective integrated total. You can't just be an expert on this particular piece because all of it's going to be integrated, Carm.
It all fits together. Just put your hands together and fold your fingers together, and there you go. Hey, let's do this next slide. I like this next slide you have up.
This is just to raise awareness, how the manufacturers address this problem. I don't talk to the people who give me a quote for me to buy one, but my understanding is they're hundreds of thousands of dollars. So this is not something that the aftermarket is going to be able to put in shops. This is something that the manufacturer uses as end-of-line calibration. Now, the point I'm trying to make here is that, that's the way it comes out. Right? And then it hits the street, and it's not going to go through one of these again in its life. The franchise dealers don't have these. We don't have these. And so from a point of view of how all this works as a totality, we have a long way to go before we're going to be able to have systems in these vehicles that can give us the same kind of analysis as this machine does today. The OEs depend on this kind of a machine. We're going to have to, have a lot of progress in this, dynamic recalibration piece that everybody wants to talk about to get to this level.
Thanks for this picture, Joe. This really shows us what the OEs have to do. And I imagine when there's a new vehicle coming down the line, the whole dynamics of that drive-on piece changes. They probably press a button and the targets move. What else would we expect from OEs to get ADAS calibration right on the vehicle if they're going to knock out a car every 10 minutes? They got to have something like this. Yeah,
exactly. And the really important point about this, Carm, is that when they think about this, they're thinking about a handful of models in their brand. We have that, 10-fold, 20-fold, right? Not to mention age of vehicles where, all right, well, this vehicle has these systems, but not these systems. And, that all of, when you start looking at all those differences, it really shows the complexity of what the aftermarket's facing in it.
Just so that everyone knows this, we're talking about slides. You can actually see them. If you go to the show notes page, we'll have an actual video of our of this episode, so you can actually walk through it. The next slide here, Joe, is, so what's next? I'm afraid to click the next slide. My brain can't take any more.
The interesting thing here is we started down a road with OBD as being a port that was proprietary, that the OEs would, stick their cable on and do some diagnostics. Very, very simplistic stuff by today's standards. Nothing like what you just showed. That has progressed, and there's all this internal communication. And I know that a CAN bus is a pretty simplistic kind of network. It comes down to a serial bus, which is just ridiculously slow. You can damn near count the bits and bytes as they go by. And everything's trying to connect to that and communicate. So the future looks very different. I mean, what we're talking about now is Ethernet in the car, same kind of Ethernet that we have at home, connecting to the Wi-Fi and so forth. And that Ethernet can connect, a lot more devices and can move a lot more information very quickly. This slide up here shows GM unveils the digital vehicle platform, 4.5 terabytes an hour. There wasn't 50 bytes an hour when we started in this business back at the OBD port, right? But now 4.5 terabytes, billions of bytes running through this vehicle. And this is 2023.
You just brought up the whole thing of perception and how artificial intelligence is going to figure this out. Well, it can't do it on a CAN bus. It has to do it on a terabyte per hour Ethernet.
That's right. And again, it's interesting, right? I mean, we all have perceptions, as you said, about, what we need. It's been a real challenge keeping up with the number of electronic control modules on vehicles for the last 10 years, right? They've gone from 30 to 50 to now there's 130 or 140 on a vehicle. Well, now what I'm telling you is it's going to start going the other way, Carm. You're going to start getting fewer really, really smart computing devices on that car. And some of these manufacturers don't want to have all the intelligence just in the vehicle. So they're going to be connecting with other resources external to the vehicle. And because they have an Ethernet backbone in these cars, they're going to be able to move information much more quickly. Electric vehicles, have a bit of a leg up because they're newer. And they're being designed with a lot of this in foresight, as opposed to the ICE vehicles. And as a result, what you're seeing is that this convergence going forward with having the same kinds of information and the control over the vehicle is going to actually require kind of a separate vehicle hardware from software. And so there's going to be this intelligence. This intelligence can adapt to different kinds of hardware. Going forward, we're not going to have these little, electronic control modules that, I need a transmission control module. And so you just replace that. No, it's going to take diagnostics on a very high performant kind of computer and then get to what exactly is the issue. Is it, is it the sensor? Is there something wrong with the program in this myriad of programs on this HPC, high performance computer?
Joe, do you believe that these modules, there's going to be less modules in the vehicle? Do you think they'll have components inside of them that will be replaced, or the whole unit would have to be replaced?
Typically, high performance computing, that hasn't been the case, Carm. From a standpoint of the kind of miniaturization of these pieces, when I hold up a cell phone nowadays in comparison to what cell phones did a decade ago, this thing has more power than even the most exotic game machine that people were building back 10 years ago. I mean, they're enormously powerful. So now you can envision having something with the same capability, having 4 or 5 of those in a vehicle, all operating on a very high speed connection. There's this great opportunity now to be able to start simulating thinking in the vehicle itself, and then to connect to ET is going to phone home and get information directly from the manufacturer and so forth going forward. The question is, how do we play in that space going forward?
Great slide here from BMW and Audi. Talk to us about this.
This is all about integration and how they are segmenting out certain kinds of activities. So you have a very kind of transactional activity going on. Some sensor has gotten some, let's just say that it's a radar unit. And so it's transmitting information. It will, in the past, it's gone directly to probably a discrete computing piece in there. They're now going to start separating that and having this information come in as one of many inputs, because they're going to need to be rationalized over time. So it isn't going to be, I'm only going to pay attention to this particular sensor. It's my job is to collect the information from multiple inputs and then come up with a way to be able to get the vehicle to perform ideally in the situation I'm perceiving from all of this collected information. And then, so now what you have is a difference where do you want to put this power? Where do you want to put this information? And the requirements and the way that they need to test and all of the information going forward from these devices is a brand new world. Very similar to what we've encountered in the last decade or two, where all this electrification of vehicles has taken us in the direction we're headed today. This kind of high performance computing is going to be a whole new world, and we're going to have to learn how to deal with it, because the OE just doesn't have enough bays.
I love what you said. It's a brand new world. And my thought was, do we realize as an industry, do our diagnosticians, our technicians out there realize the stuff that's being worked on that is really going to have an impact and an effect on their job in the future? And then finally, does the consumer have any clue? And, why it costs what it does to do what we have to do to put the car back in shape?
I mean, you've seen the price escalate on vehicles over recent history. And I think that how much these vehicles are going to cost is a real question. And what that means to individual vehicle ownership. Is there going to be an even older fleet of vehicles in the near future, Carm, where people just say, look, these are so expensive. I need to keep Bessie for another 10 years. I made an investment of $45,000 in this vehicle, and I need to keep it until the wheels fall off. Well, all of these pieces are part of keeping it so it's safe and dependable in that period.
Is there going to be enough computer power out there for our shops, for our vehicles to really run? I mean, I heard some stuff about trying to improve, move the cloud out to outside. What do you know about that?
I don't know much about it because, quite frankly, the OEs are not as forthcoming as you might hope in a lot of this stuff. And then secondly, not to blame them directly, much of this is not being done in the walls of the manufacturer, right? Much of it is being done to third parties. And I know the likes of Google, for instance, have become very active in a lot of the connectivity options and processing capabilities of high performance computing in vehicles down the road, because they're the experts on high performance computing. 4.5 terabytes an hour. That's a lot of data, and deciding what you keep and what you don't keep is going to be a real challenge. I'll share one quick story with you, Carm. I was at an SAE conference, and there was a fellow from one of the manufacturers who got up and was talking about ADAS equipment and keeping the information and being able to restore a crash site and et cetera. And he was presented personal experience. He was a part of triage that was done post the accident. The vehicle itself that caused the accident wasn't involved in it. So what happened is this guy goes screaming down the road, runs a red light, and everybody starts crashing into each other to avoid him. Now, the fact is that he didn't have a crash incident, so the typical piece of taking what's in the buffer and committing it and so forth wasn't done. And so now they had to try to go back and using cameras and seeing him in the intersection and trying to figure out where he is, go back, and the data that had been collected that was kept, the job of restoring that, they only had a week to come back and say what the information was, the status of his vehicle, whether it was accelerating at the speed it was going and all the rest of that. They only had a week to restore it. And he said, we couldn't do it in a week. To go back in and try to get this data that we had archived, unarchived, and be able to supply it to the court couldn't be done in the period of time that we had been given.
It wasn't indexed right, I'm sure. And, it was just there and they couldn't figure out.
Well, it was there, and that's a lot of data to play with. So, this is all going to become part of the new world, Carm. Everybody has to start trying to figure this out.
Well, look, thank you so much for going even beyond our discussion on ADAS and bringing us to, if you will, the fringes of the new and in the future. I know you're going to have something at Virtual Apex, and I'm not sure if this episode will come out before or after, but here's the deal. aapexshow.com/register. Just go there. It's free training. Joe's going to have an emerging technologies presentation there, and I'm sure if you register but you can't maybe make it, I somehow believe that Apex will allow you, with your sign-on to go back and catch some of the stuff that you may have missed. Anything you can watch or hear the episodes that Joe and I have done together. He's the guy, Joe Register. So please partake in anything Joe is providing because he's connected.
In a connected world, you've got to be connected, Carm.
Well, thank you so much, Joe Register, Emerging Technologies, AutoCare. As always, I learned a lot. You continue to make me a Star Trekky guy when it comes to, the stuff coming true for the future and this great tech that we're working with in the automotive. Wow.
Oh, it's amazing. And, it's going to continue to just evolve while we're watching, Carm. It's exploding.
Thanks, Joe.
Thank you. Always a pleasure.
Thanks for being on board to listen and learn from the premier Automotive Aftermarket podcast. Until next time.